Hi, today we'll talk about individual moving range chart. Individual chart and moving range chart. These two has been joined together to form IMR chart. Individual chart is nothing but plotting of individual data which comes from a process, and it gives you an inference, it gives you a trend to know whether your process is stable or not. Depending upon the individual points, individual data, you can make an inference whether there is any assignable cause for your process which has made your process unstable. And moving range chart is the range between two consecutive data points which has a different inference. So combination of this individual and moving range chart is called IMR chart. Now this chart can be prepared in Minitab, and it can be done in Minitab very easily. You can give the data, you can feed the data to the Minitab software, and it will give you back IMR chart ready-made. But what if your system is not loaded with Minitab? What if you don't have Minitab software? For in that case, you need to have an Excel. Excel is very powerful tool, and by using this Excel, you can automate this with a real-time data, and you can uh, calculate, or you can visualize the process stability, uh, and you can have you need to feed the data, and your graph will automatically change. This can also be done if your process is giving back your data, and it is being stored in a SQL server, and from SQL you can fetch that data and put it in this Excel uh, table, and it will give you the result, and that control chart can be displayed on the SCADA system of your machine or of your process. So how to make this IMR chart in Excel? Let's get started. What I have done is I have made a template template of the data which is being recorded from the machine uh, by an operator. This is done, the data has been taken manually from the process by operator. With there is a reference number of job. Each and every job was measured for a particular parameter, and that parameter was recorded by the operator. Now we need to find out the control chart, the IMR chart for this data. So before making this IMR chart, what I'll do is I'll convert this into a table. This table will help us in inputting some new data to the system, and the system will take this data and plot the graph on a real-time basis. Okay. So the next thing is you need to calculate the X bar, I bar, the average of all the individual data which you have taken. So we need to find out the average of all the individual data. Next thing is you need to you need to find out the moving range. Moving range, what I said is the range between two consecutive, the previous data and the data itself. What is the range between these two data? So it would be max of these two data minus min of these two individual data. Okay. Now this data has no previous value. This is the first data, and we have no previous data for this. So you need to delete this. You can delete this. We'll delete this afterwards. Now we need to calculate the average of the moving range. Why we need to calculate this? Because we are also calculating the moving range chart. So we need to have the center line of the average line of moving range. Hence we have calculated this. Now for calculating individual chart, we need to have the sigma value. Sigma is the standard deviation. For IMR chart, we need to calculate sigma with a range method. For range method, the formula is sigma is equal to R bar divided by D2. Okay, sigma is R bar by D2. So we know the moving range. So R bar is there, and D2 value is nothing but 1.128, and one more constant is there, D4. D4 value is 3.267. This D4 value will be calculated to know the UCL value of moving range. That we'll calculate further. So for sigma value, we need to have IMR value divided by the D2 value, which is 1.128. Now we have calculated the sigma value, standard deviation. Now we need to calculate plus minus 1 sigma from the average, and plus minus 2 sigma from the average, and plus minus 3 sigma from the average. So for that, what we need to do is I bar or X bar plus 1 sigma value. For 2 sigma value, we need to have X bar or I bar plus 2 into sigma value. For 3 sigma, we need to have I bar plus 3 into sigma value. Okay. Now we need to calculate the lower part of the graph. For that, we need to we need to change the operator, because we are calculating the negative part of this, lower part of the means lower control limit. So we need to calculate this as, okay. Now we have calculated plus minus sigma value, all the 1 sigma value, 2 sigma value, and 3 sigma value. Now lastly we need to calculate the IMR UCL value, MR UCL value. So MR UCL value will be MR bar into D4. D4 is 3.267, and it is a constant. So we have calculated the MR value also. Now what we need to do is we need to find the uh, individual chart. For individual chart, we need to calculate only individual values. So what we'll do is we'll take this chart, whole chart, or yes, whole chart, and what we'll do is we'll insert line graph, and this will be like this. Now this is a bit confusing. So what we'll do is we'll separate individual chart and the moving range chart, and we'll separate it out, and after that we'll club it. So for this we need to go to select data, and only we'll select the individual chart parameters, like the individual points or individual data, the X bar chart or I bar chart. Will not select this moving range. We need not have sigma value, it's of no use now. It was used for calculating this X bar plus minus 1 sigma, 2 sigma, and 3 sigma. And MR chart, MR UCL will be used in MR moving range chart. So this type of graph would be there. Now you can format this graph. You can name it as individual. Now you can name this graph as I chart. Okay, now you can format, like you go to here, you give it a pointer, you give it a dash, you color it with red, and this is your, you give it a color, you set it to 1.5 points, and you give it a dash. This becomes your tolerance, control limit tolerance. And this is your 2 sigma level. So what you will do is you will go and you will give it a pointer, you will give it a color, say I will give it purple color, and I will give it a small dash, and same for 2 sigma minus, we'll go to and give it a color of purple, we'll select it as pointer, and we'll set it with small dots. Okay, uh, so sorry, not this graph, this one, this will set it as purple, and we'll set as one pointer, and we'll give it a dash color. This is 1 sigma, so we'll keep it as green. Okay, now this also will keep it as green, and we'll give it a pointer, and it will give a dash type value. And for this, we'll select bold blue color because it's a center line, average line. We'll give it 1.5, and we'll give it a dash type like this. And because these two blue color are matching, so we'll convert this into different color, say this, and we'll format this, the marker value, to a built-in, sorry, not this one, I have selected the wrong, I have to select the trend. So I have selected this trend, selected this trend, marker, marker value, and I will built in, give it a color, say this. Okay, so this becomes my individual chart. So I will cut this chart and I will place it somewhere here, and we'll do again for, say, again for uh, we'll insert a new graph, and we'll select data for MR chart. Select data, we need not this one, not sigma value, not these, all these things, only MR value will be there, and this will give me a MR chart. Okay, now you can format this also, no problem. I will cut this and I will place it here. Okay, I will place just below this. Place just below this. So now what you have your I chart, you have your MR chart. Now this will be a dynamic chart. Whenever a new data comes, say you have a new data in shift 2, you have MAT 2815 job, and that value is 2.0 point, say 78. When you will plot this, your graph would be changing. This came here. So accordingly, your graph would be changed, and you will know my value went above UCL value, and there is some special cause, and you will take action upon that. There are various rules. There are 8 different rules for individual charts. Uh, those can be, uh, we can discuss that also, but we'll discuss it in a different video. So hope this IMR chart in Excel would help you in analyzing your process stability, and this can be automated. And if your process is having uh, a log of data, then that can be fetched from the SQL server, and from SQL server you can shift it to this simple Excel table, and this graph can be placed at your SCADA station, where you can monitor a real-time parameter, the CTQs, the critical to quality parameters, and you can make an inference out of it, and you can monitor your process stability. uh, I hope this video was fruitful. If you want, we can please message me so that I can share this file with you. Thank you so much. Take care.